Low-latency IoT applications such as autonomous vehicles, smart cities, and virtual reality are all building the use case for further extending compute infrastructure towards the network edge. This panel will discuss the rationale for placing pools of compute infrastructure further out into the network and the applications that will require new cloud computing topologies such as multi-access edge computing and also fog computing. Next to me is Renu Navale. She's director of the Network Platforms Group, that at Intel. Next to her is Schmitt. He's vice president and fellow of Extreme Scale Infrastructure at Dell EMC. And next to Ty is Patrick Lopez. He's head of network innovation at Telefonica. And panelists, welcome. Well, thanks for being here. Of course, we're here in Barcelona, Spain. We're talking about sort of the evolution and revolution, if you will, of edge compute and maybe its impact on 5G and 5G technologies. Patrick, I want to start with you. We were talking just earlier on the way to the studio here about edge compute and it being really the most 5G-ready technology. What did you mean by that?
Well, 5G is a lot of things. It's a new radio. It's going to be a new core. It's going to be a new network end-to-end. Edge computing is one of those technologies that started maybe 3 to 4 years ago in the standards, and it's coming now to a point of maturity that is ready to deploy in the market. So that's what I meant by that statement, where we're waiting for 5G to be deployed in the next couple of years. Edge computing is probably the technology that is 5G-like with the highest level of maturity. And obviously, within 5G, edge computing will get much bigger and will benefit from all the technologies that 5G is going to bring, but you can deploy edge computing capabilities now, actually, in advance of 5G if you want.
Yeah, and I think from an infrastructure perspective, the challenge is going to be how to enable that span or that edge proximity in places where there isn't necessarily infrastructure, power, security. And so as the edge from a physical standpoint is becoming defined, being able to package and wrap securely the critical IT gear that's going to go into these is very important.
And to add to what Patrick and Ty said, I think 5G is accelerating the need for low latency services at the edge. And this is resulting in the entire ecosystem, the industry ecosystem, looking at placing edge compute, pools of compute, storage, and networking at the edge. Intel is actually working with Dell in one such demo at Mobile World Congress. We have our Intel Xeon D processor that's used in the Dell equipment. It's being demoed there, and this is ready for edge applications, ready to be used in edge infrastructure applications. And this points to what Patrick was saying, that there are cases where we can have deployments today that's almost as a precursor to 5G networks.
I think that's a great segue, and I think I know what you're about to talk about. From the customer viewpoint, can we talk about maybe some of these 5G use cases, and then Renu, if you can continue as well.
Certainly. So edge computing, what is it? It's providing a mini data center just very close to the user. And when I say very close, it's a few kilometers. So what does it mean? It reduces drastically the latency. The latency is how long it takes to send a bit of data from your phone, from your PC, to the cloud, to the internet, and back. And basically, the larger the latency, the longer you have to wait for the data to come back, and the poorer the user experience. Now, you might not notice very much when you do an email, because you send your email and you don't really know when it's going to arrive. So whether it's 1 second or 1/3 of a second doesn't really matter. But you notice for application that requires a lot of processing powers. So right now, we're starting to see the emergence of augmented mixed virtual reality, for instance. So if you were to imagine that you had glasses, augmented reality glasses, where you're going to have in real time while you're looking at your environment, things are going to be superimposed in the glass on your field of vision. In order to do that, you need to be able to do that in real time. And that video that is created, those pictures that are created, require a tremendous amount of processing power. And that's where edge computing provides all its capabilities, basically. Having data centers located very close to the user allow for this type of use case that are going to change our everyday life. And then there are other added benefits to that might be more from us on an infrastructure side. Basically, when you imagine that content, and particularly video content, is going to increase dramatically in size with 4K, with 8K, and we mentioned virtual reality, it takes very big pipes to carry all that traffic. And if you can actually cache some of that traffic very close to the user, you're actually saving a lot of the transport costs associated with that delivery. So in the future, when you're going to watch 4K or 8K content, a large majority of that content is going to be cached close to where you are, so that you can have a great user experience and you don't have to wait and there won't be any buffering for you to be able to access that content.
Renu, from Intel's point of view, any 5G use cases you can share?
So the way when I think of 5G, I think of it as a transformational catalyst. It has the power to transform several different types of vertical industries. Just like electricity or the printing press in the past transformed the way we live. 5G has the capability to transform the way we live and work and play and learn. Intel's been working with different vertical industries, retail, airlines, healthcare, automotive. All of these industries will likely transform because of 5G. And we're at the tip of the iceberg with respect to use cases. I think there's going to be a lot more different types of services and use cases that involve 5G technologies, including low latency, the enhanced mobile bandwidth that we have, the performance and compute and storage that we'll have at the far edge. All of that will create new types of services and use cases that will transform each one of these different individual vertical industries.
If I can add maybe to that, I mean, a few user benefits or use cases for users that can change people's perception. For instance, edge computing, it's bringing the cloud very close to you in a very localized manner. So it means that, for instance, there's no reason that your pictures from your storage, your cloud storage, be stored in, I don't know, a data center over in, I don't know, Netherlands or Australia, or who knows where at the end of the day. They could be stored just there, very close to you and under your control. Of course, for enterprise, that has great benefits as well, because some of them, for instance, they have regulatory or security provision that prevents them from having their data stored very far away. So that's another benefit for this type of application. And then last, we were talking about low latency and augmented reality. You can think also about just very simple services. Well, simple. We all heard about autonomous vehicle, for instance. We have seen that they are coming. Right now, they are truly autonomous, but in the near future, they will need to interact with their environment. And in order to do that, they will need to be able to count on processing power outside of the vehicle so that they know what are traffic conditions, for instance. These are very simple use cases. Today, you have the map in your GPS. Tomorrow, that map will be in the cloud. Why? Because you will know what the traffic is in real time, and you'll know whether there's a deviation or an accident in real time. So never again you will be in your GPS and trying to turn right on the road that is one way. That won't happen.
Ty, in your opinion, what applications or functions do you think MNOs would have to push out even further to the edge?
We're seeing a number of different types of applications, whether it is complementing the autonomous vehicles, ingest of massive amounts of content that from a latency standpoint does not make sense to take that back to a core facility. They would like to have localized video capture done in urban or small regional type micro facilities. A lot of customers, content delivery, large video, high resolution video, gaming. When we look at the edge, there's so many different customer usage models, and I think to some extent, people are trying to determine what the unified taxonomy is for how we refer to the edge. because it means different things to different people. For me, it's more physical in nature. Other people that have different applications, their edge may be the ship that they're on in the ocean. It may be their mining corporation. It could be this autonomous vehicle situation where you have local ingest. For others, it's just anything outside of their core data center. And so lots of different usage models tied to
Well, I think also, it's worth noting that there are many edges. It's just not one edge. And I think when the industry started thinking about edge computing, it was very much a mobile use case. And then little by little, it has evolved to include a number of different edges, such as the central office, for instance, such as the enterprise edge. So I think that we're going to see edge computing being deployed in a lot of different situations for a lot of different use cases. Another use case, for instance, is robotics. Any enterprise that has robotics equipment that are today not really fully autonomous because they are cabled for alimentation and for provisioning and for motion. Well, all these robotics equipment, they will be able to, in a 5G environment with edge computing, to be completely autonomous and being able to have full motion and detect the environment, whether human or whether other robots, and basically interact with each other. And that's only possible if you really have a lot of computing power very close to it. So that's what edge computing is for.
Yeah, we were actually, it brings to mind a customer example where they were looking for actually not only edge, but mobile edge applications in the medical space, using medical robots. And they we were actively looking at how to package not only an edge compute system, but an edge compute system that is mobile.
Yes.
So that you can bring the compute power to wherever it needs to go. So very exciting.
And if I can add another example, so Intel actually worked with the Alibaba Cloud Group, and we used multi-access edge computing, the multi-access edge computing technology to do facial recognition for security surveillance. So it was, again, massive amounts of pictures and images that you have to analyze, and you don't want to take that back to the cloud all the time, so you're analyzing that at the edge. And we were also working with them using our flexible radio access network technology and FlexRAN and FlexCore to do traffic management. So not only get data from traffic management, but also analyze it and predict, future flows of traffic as well.
Yeah, and Patrick, you mentioned earlier when we look at it, when you look at the landscape of the edge, and the edge means different things to different people, but you have the input devices, right? Our phones are part of the edge, right? They're input devices. And the further you get towards the core, it becomes a latency, right? The latency requirements will drive up or down where you go physically and logically on the edge.
Absolutely, and that's the exciting part of what we're doing right now. Basically, we're measuring what's the benefit of bringing what kind of function where in the edge, all the way to the device, all the way to the home of the customer, or a little bit closer to concentration points and central offices, or in centralized data center, or in the cloud, and measuring for each one of these functions in each one of those locations, what's the impact on the customer experience.
So you're looking for a value per microsecond or nanosecond of latency reduction.
We believe that as far as the market goes, this is probably a great opportunity because edge computing will facilitate the emergence of services that are otherwise impossible, but also will provide for existing services a premium experience. And we think that if you can measure that premium experience, there will be companies that will be actually willing to participate in that experience. And we feel one of the important parts of edge computing is also to have an open edge. So in Telefonica, we're actually designed our own edge computing platform using open source components, and it's an open platform, which means that we can deploy services from third parties. And what that means, we believe, is that we will see benefits of deploying services very close to customer, and we will see the emergence of a market there because people will pay to provide to a certain part of their customer base a premium experience. And I think that's a great economical incentive for the whole value chain.
Yeah. I completely agree. I think there's a balance of low latency versus kind of the total cost of ownership, because it's always a little bit more expensive to have everything at the edge. So you're always going to balance that. And then the second is the services monetization, because this is going to drive different types of services and experiences that the users will want to pay for.
So I know Patrick just gave a bit of a futurist answer to the topic today. Ty, I'll start with you. If we were doing this time next year, as far as 5G network architectures, as far as edge computing, as far as the verticals and the sectors that are impacted, industrial, smart cities, VR, AR, what do you think we would be talking about?
You know, I think the industry moves at the pace that it needs to move at, and I think it's not moving as fast for some as they would like. I think what we're seeing, even if you go back 2 or 3 years, you were seeing companies and technologies both flow down the path of least resistance, or growing out of nothing because there are new usage models, there's new opportunities that we did not know a year ago. And so I believe what we'll see is from a physical standpoint is adoption. We'll start seeing more usage, proof of concepts, or the first leap or step from customers to truly get this capability to whatever they define as their edge, to begin measuring data and metrics to help course correct or substantiate what they're doing. I think we'll see a lot more of that. We are seeing some of that. It's growing, but that's where we're going to see big leaps and bounds in technology shifts. Is that first adoption, trying it out, breaking it, learning from it, redirecting, and I expect we'll see a lot of that in the coming year.
Renu, this time next year?
So I think we've been on this journey of virtualizing our network infrastructure to make it more scalable, flexible, programmable. I think you'll see more and more of our network infrastructure becoming virtualized as it gets ready for 5G. You also see, like Patrick said, bringing cloud-like architectures towards the edge. So you'll see more deployments of multi-access edge computing, FlexRAN, flexible radio access networks, and FlexCore at the edge. But as the network also becomes virtualized or in preparation for 5G, you'll also see the concept of using things like network slices, which is composable, dedicated pieces of virtualized network that you can use for different vertical industries, and provide unique or dedicated types of quality of service for those specific types of use cases. So I think you'll start to see more of that. Will it all be deployed at mass scale next year? Likely not, but you'll see more and more uses of these technologies starting to emerge at different places in the edge, especially.
I feel like Intel's always maintained an integral and almost like a bedrock position in the industry, right? That's no secret. And Dell EMC as well. Dell EMC, you've made some changes over the last couple of years, 2-3 years, as far as your approach, and that has changed maybe in a good way your relationship with the carrier community. Can you just touch on that for a moment? I know that wasn't part of our conversation, but since Telefonica's sitting.
I think it's really a statement of more call it vertical integration. What we've always tried to do is view as big or as much of a system as possible when we're trying to solution something for a customer, and that's difficult to do unless you have strong partners in areas that you don't have that capability in, or you own it yourself, or you grow it organically. And I think the union of Dell and EMC, VMware and others, we have now all these gaps are filled, and we're able to come to customers with a complete system solution approach. I think we're seeing it's very, very compelling.
Patrick, I'll finish with you. The customer sitting here on the panel. How is not only specifically to you as an individual, but as a company, how has your relationship changed with the vendor community over, let's say, the past couple of years? And you can refer to edge compute as a topic.
Well, it's a complex question because, obviously, Telefonica is almost a 100 years old company. I think we've spent over the last 5 years close to 38 billion euro in investment to build networks to connect people. And I mean, that could not happen without our partners and the fabricants and the vendors that help us deploy our network. That situation is evolving all the time in the sense that we are committed to provide more and more value to our customers, to connect more and more people. And, you know, we were speaking briefly about network slicing. I think it's a great opportunity because that allows us to address different segments of the population going forward. What it means as well is that we no longer are going to look at our networks as just one template that fits all our customers all the time. And that's a great opportunity because it allows new vendors, new fabricants to get into the value chain. And certainly Telefonica has been one of the pioneers, if not one of the original operators to deploy a fully virtualized architecture. It's called Unica. And having a virtualized network, having a programmable network is great for vendors because it's basically an open environment. Because it's standard-based, because we're using tools such as open source Mano, which is a standard-based ETSI approved open source orchestration system, you can guarantee that vendors can come into that environment with minimum effort of integration. And that's good for everybody because new vendors means fresh ideas, allows us to lower costs, which means that we can actually ultimately connect more people. So that's really the dynamics that's going on right now.
I think it's one thing that's interesting that I've experienced over the last number of years in doing these types of panels and moderating them, and just kind of taking a third-party point of view and listening to you guys talk about what your core competencies are, is that it's just as important to talk about how the relationship is evolving between the three of you, and in the industry just as much as the technology itself, because there's two facets to making sure that edge compute as a technology evolves and evolves at a fast pace. So that's something that we like to touch on. So Patrick Lopez, thank you for being with us in Barcelona. I appreciate your time. Ty, thanks for your participation and your other contributions to NMG. We appreciate that, and your sponsorship. And Renu, thank you very much. Intel's been on our programming for about 8-9 years now, so and in Barcelona, by the way, so we appreciate you being with us.
Thank you.
Thanks for your time. And once again, from the NMG studio right here in Barcelona, Spain, we'd like to thank our speakers. And for more information on how to be on our program in 2018, you can contact us at thenetworkmediagroup.com. So long.